Assalamualaikum warahmatullahi wabarakatuh and very good morning to everybody. Okay, first of all, I would like to introduce myself. My name is Zainab binti Mohamed Yusof. I'm from the Department of Water and Environmental Engineering, School of Civil Engineering, Faculty of Engineering, Universiti Teknologi Malaysia. Okay, today I would like to present my study on the title of the Erosion Morphology of an Embankment Failure. And this study, we have collaboration with my colleagues. There are Professor Dr. Mahiri Abdul Wahab, Dr. Zuhilmi Ismail, and Dr. S.Amerudin. Okay, now I would like to talk about what is the embankment dam. Okay, the embankment dam, or somehow people call it as an earthfill dam, is a dam, or somehow people call it as a levee, dikes, and barrier, and its function is widely used in flood defense, in power generation, water supply, transportation, and sediment retention. Okay, here I show you the example of the embankment dam, and when the embankment breach or fail, so what happened to the downstream valley is it will cause the massive disasters such as the flooding, losses of life, destruction of properties, interruption of services. So it's very important to study the embankment failure, especially for the emergency planning and for the water security. Okay, a little bit on introduction. Okay, overtopping is a common mode of dam failures due to the inadequate spillway discharge capacity. And studies from Zhu and Zhang in 2009 indicates that embankment failure mostly occurred due to overtopping with the highest percentage, which is 96%, followed by the seepage 35.6%, sliding 55%, and unknown causes by 3.4%. And the embankment failure may cause loss of human life and damage to the structures, economic losses to the businesses. Okay, Fred in 1993, from his study, he found out that the earth dam are subject to possible failure from either overtopping or piping, which erode a bridge through the dam. Meanwhile, Orendorff et al. In 2010 found that the breach of an earthfill dam and the subsequent release of large volume of water can be devastating to downstream communities. Okay, like what I've mentioned previously, it will cause the damages, to the downstream valleys. And the observation of the past dam failures have indicated that the bridge shape is usually triangle, and its width and depth grows during the overtopping. And many studies has found out that the final the final shape of the breaching actually would be a trapezoidal shape. Okay, this is the big theory on the overtopping flow. As you can see here, we got a dam here. Okay, and we have the flow which is overtop on the dam, water flowing from the left. Okay, and then we have flow regime here. Okay, and then we have the erosion zone. And this study is conducted by Polish et al. In 1998. From the study, we found out that the erosion zone is depending on the flow regime. Okay, so flow over the embankment is characterized by two types of the flow, which is the supercritical flow and the subcritical flow. And this type of the flow is depending on the part number. Okay, zone 1. Okay, zone 1 is a zone where less erosion happen due to the subcritical flow approaching the embankment. And the flow velocities and shear stress above the crest, this is the crest of the embankment, are relatively low, meaning the erosion is less Then when the water passing through the zone 1, okay, it called the zone 2. Okay, zone 2 is a transition zone from the subcritical flow to the supercritical flow. And this zone exhibited high stresses due to the changes of energy slope. Okay, so this is the transition zone. And the last one is the zone 3, whereby this is the very high potential of erosion. Okay, at this zone, the flow accelerates rapidly along the downstream slope here, that will increase shear stress at the downstream corner of the crest. So at this area, at this zone, it will experience a very massive erosion, especially at the toe. Okay, the next slide telling you the breaching process. Okay, this study has been conducted by Chimnasari in 2003, and from the study they found out that during the breaching time, the dike crest, the dike crest is continually eroded and transported to the downstream due to the slope sliding failure. Okay, we have the hydrostatic pressure at the back of the embankment here, and the failure is due to the interaction between the strength of the embankment materials and the overtopping water forces. Okay, so we have two mechanisms actually, from the hydrostatic pressure from the upstream, and due to the weakness of the material. Okay, so it caused the erosion or the sliding of the embankment. The depth and the duration of overtopping and the erodibility of the embankment materials are the key parameters that need to be investigated. And once erosion initiates at the toe of the dam, the head cuts form at the toe and then advance upstream until the crest of the dam is breached. Okay, this behavior of the breaching erosion has been found in WAH 1998. Okay, so based on that scenario, so this study is aimed to analyze the breach pattern, and then to analyze the breach hydrograph and calculate the volume loss, okay, due to the breaching. To do that, we have done the experimental study in the laboratory. So we have the input data of the inflow rate, which is 0.8 times 10 power of minus 3 meter cube per second. And at the embankment itself, we allow for a notch, which the size is 10 meter height and 3 meter wide. The function of the notch here actually is to initiate the breach or to trigger the breach, so that we have very consistent breaching behavior. Okay, here is the experimental setup that we have built in the laboratory. So we have a long channel here. Okay, this is a channel, and the channel has 11 meter in length, 0.6 meter in width, and the depth is 0.5 meter. And the right diagram shows you the schematic diagram, the plan view, and the front view. Okay, so we have the two tanks here, the first tank and the second tank. So water will be pumping from the tank and then through the channel here. This is the flow. Okay, this is the embankment. And here we got two camera installed, okay, on the top and the front to capture the pattern or the behavior of the breaching. And we also install the V-notch wheel here at the end of the channel here to measure the breach discharge. Okay, so the length is 11 meter, the width is 0.6 meter, and the height is 0.5 meter. Okay, the embankment that we have set up in the laboratory is made of the medium size, where the grain size of the medium is ranging from 0.5 millimeter to 0.2 millimeter, and the embankment has the slope of 1 vertical, 3 horizontal, and we have the crest width around 0.1 meter, and the height of the embankment is 0.1 meter. The below figure shows you the compaction work that we have done. So we compact the embankment layers by layers, so that we can get the uniform load of the material. Okay, this is the result of the bridge hydrograph that we obtained from the experiment. So here is the schematic diagrams, okay, where how the flow is flowing from the upstream to the downstream. And here we notice there's a distance, right? After the bridge, the flow will be flowing through this distance and then enters to the second tank before it overflow to the notch near here. Okay, so the notch here, we use this equation to calculate the discharge, to calculate the bridge discharge. Okay, so from the hydrograph that we found here, so we can see it is a delay time here, right? So the delay time is around 54 seconds. Okay, 54 seconds before the bridging starts. Okay, why? Because we have uh, the length, we have the length for the flow to flowing from this point to that point. Okay, so here is the cubic that we obtain here is 3.63 times 10 power minus 3 meter cube per second, whereby it takes about 35 seconds to reach the peak, right? To reach the peak before the flow decreases rapidly until it comes to the steady state condition for around 20 seconds, right? Okay, and this is the result of the bridge patterns. Okay, so we can see here. Okay, so the diagram A shows you the water flowing into the notch. All right, so this is the area of the notch that we allow the water passing through the notch, and this is the final bridge shape of the bridging top view, and this is the front view, and this is the sediment deposition viewing from the front. Okay, so we can see here the shape of the bridging is like a trapezoidal, right? Okay, so once we have done the experiment, now we want to calculate what is the volume loss. The 3D grids that we created to plot for the volume loss in 3D figures. Okay, so this is the location of the embankment here, of the embankment. So the grid is 200 centimeter, equivalent to 0.2 meter, and the width is 0.6 meter. Okay, so this is the location where we place the embankment. Okay, so this is the crest, this is the upstream slope, and this is the downstream slope. Okay, so the size of the grid is 5 times 5 centimeter. All right. Okay, so what we have done here, so we measure the sediment height using a point gauge based on the grid point here. Okay, and the data was plotted in three axes, X, Y, and Z, whereby in Y axis is the sediment height at each point of the grid intersection of X and Y. So from there, we got the profile of the elevation of the bridge embankment. Okay, this is the final results of the bridge embankment using Surfer 8. Okay, so this is before the bridge and this is after the bridging. Okay, so in this method or in this program, so we use the three method of the volume calculation. The first one using the trapezoidal rules, Simpson's rules, and the Simpson 3/8 rules. Okay, so the first one we calculate the volume of the embankment before the bridge. So we got it around 0.239 meter cube. Okay, a bit similar values for all these three methods. And this is the final one after the bridge here. So we got the value is more or less 0.144 meter cube. So so here we can say that using all these three methods, we will get similar values, right? I mean, slightly similar values. So the volume loss that we calculate for the breaching or from the experiment is 0.0098 meter cube, and the volume of the remaining embankment is 0.014 meter cube. So, in conclusion, we can say that finding shows the percentage difference of volume loss for all the methods calculated in Circle 8 was less than 0.1%, and the percentage of volume loss due to the embankment failure of the study is approximately 41%. So I think with that I end my presentation. Thank you very much.